All right, guys, real quickly going over our warm up here. Part A. What did you get for number 1 on part A? So we're supposed to multiply, which means -2 times -2 times -2 equals what? What did you get, Xander? -8. Excellent. -2 times -2 is +4 times a -2 makes it -8. Fractions, remember, with multiplication, we just go straight across, straight across. So 2 times 2 is 4. 3 times 3 is 9. Can we simplify that fraction? I do not believe so. With number 3, before we can multiply, we have to change to improper fractions. So remember, we say the whole number times the denominator. What's 1 times 2? So we're multiplying this 2 plus the numerator is, so 2 plus 1 is 3 halves. So this is really 3 halves times 3 halves times 3 halves. What's 3 times 3 times 3? 3 cubed is what? This is when we should start remembering. 27. And 2 cubed is 8. So if we simplify this improper fraction, we're asking how many groups of 8 can I take out of 27? 2, and then another one. So we can take a full 3 out because 3 times 8 is 24. That leaves me with a remainder of how many? 3 eighths. Yep, 3 and 3 eighths would be my answer for number 3. Here, -3 times -3. Is this one going to be positive or negative? Positive, because we have an even number of negative, right? So this is 9. This is 9. 9 times 9 is 81. Devin separated a number of coins into 5 piles with 7 coins in each pile. So we have 5 piles times 7 coins. Devin calculates the number of coins using 5 times 7, but his friend calculates the number of coins using 7 times 5. Are both of them correct? Yes or no? Everybody? Yes. We have the commutative property of multiplication, so you can multiply either way. Same thing with addition, right? Doesn't matter what order we're in. Fantastic. All right, go ahead and slide that into your folder, or you can stick it in your packet or whatever. That way, when we have another chance, we're gonna get going. Today, we're moving on to 1-2. If your 1-1 is not complete, it is now homework. Remember, you have lots and lots of things that you can be using as resources. I've recorded all of our classes since we started this module. So you can use that. You may also use this resource I'm showing you now. Remember, when you log into Clever, you click on your Red McGraw-Hill app. You don't need to go there now. I'm just reminding you. And then you're going to go to Reveal, and that will show you kind of our agenda on the calendar today. We're going to start to multiply and divide monomials. So we're going to view that. You should be in your packet on page, yes, it should be 13, right? Because we completed with 11 and 12 on Thursday. We had some time in Alex on Friday. Fantastic. So it should look like this. I don't know if you can see that. Okay. So first we're going to explore our product of powers. Let's do that as a class. So we're going to get there eventually, but it's going to show you a few things first. As far as this lesson goes. Let's do second time. Thanks. Even if you don't have a packet, you can grab an Alex packet, a module 1 packet. I'm not sure you should have had those, but. All right, so a comet is an object in space consisting of ice and dust left over from the formation of stars and planets. The speed of a comet can vary, but some comets have been known to travel over 1 million miles per hour. That's pretty darn fast. So suppose a comet is traveling 7 to the 7th power miles per hour. How can you determine how far it can go in 7 to the 3rd hours? How could you determine how long it would take for the comet to travel 7 to the 10th miles? What would we do? What do you think? Any ideas, William? Okay, so you could expand it. You could write out 7 times 7 times 7 times 7 times 7 times 7 times 7. And then what would you do with the 7 to the 3rd? Multiply it? What would you do? We would multiply it, right? If we have miles per hour, to get rid of the hours, we would multiply it by the number of hours times 7 to the 3rd. And if we wanted to get rid of the miles to get the hours, we'd actually have to divide it by that. So the first part, we would say 7 to the 7th times 7 to the 3rd. The other one, we would say 7 to the 7th divided by 7 to the 10th. And you're going to learn how to do that in this section of our module. All right, so just today's standard, remember we're in 8th grade. We have to know and apply the properties of integer exponents to generate equivalent numerical expressions. And so I need to change our I can, right? I can use the laws of exponents to multiply and divide monomials with common bases. That's what our new I can statement is going to be for 1, 2. And here are some things why. How can I use these? So we have to reason abstractly and quantitatively. So I can use reasoning of repeated factors to explain why the product of powers and the quotient of powers properties make sense. So now we're hearing some vocabulary and you might be thinking, I don't know what that means. So these are things we have to firm up as we go through this lesson. What are these vocabulary words, right? What does that, those big things mean? What's product of powers and what's quotient of powers? Model with mathematics. I can model a real world problem with an expression involving exponents in order to simplify the expression to solve the problem. Well, there's a lot more big words too, right? So we're going to break all that up. And we have to attend to precision. I can clearly explain why coefficients are treated differently than exponents when simplifying expressions. So we're going to have exponents and we're going to have coefficients. You guys know what coefficients are? What are they, AJ? The base. You think it's the base? It's not the base. It's actually going to be a number in front of a variable. That's going to be our coefficient. Good guess, though. Fantastic job guessing. All right. So what vocabulary will you learn? Well, we're thinking it's probably going to be a lot. So on, oh, they don't have it the same thing like they did before. Oh, they do have some vocabulary off to the right there. You see it on page 13 and in your right column. What does the prefix mono mean? Anybody know? What do you think, AJ? One. Mono, one, same, could be one thing, would be the same. Product of powers properties. So based on the terms product and powers, so first of all, what does product mean? What's a product? The answer to what kind of problem? The after result of what type of operation? No. Product. You take two numbers and multiply them together, you get the product. So that is something you must know by now. That's something we've been working on for a long time, products. And powers. Powers is what we have been talking about. Remember, powers is the value of our exponent, right? Okay, so we're going to be multiplying powers together. And teaching you how to simplify them. Quotient of powers, same thing, but what does quotient mean? What's a quotient? The answer to what type of problem? Division. Excellent. Fantastic. So instead of multiplying powers, like our product of powers, we're going to be dividing powers for our quotient of powers. And term, what does term mean in subjects other than mathematics? What's a term? Think about the elections coming up. David. It could be a length of time, like I serve a certain term. A term could be a vocabulary word, right? It could be just a word we're learning. Term, interesting. Okay. I know this launch stuff is a little bit slower than you're used to, but that's okay. So how can you simplify a product of powers with like bases? It says you will use Web Sketchpad to explore this problem. So in your, you want to try and get there, or do you want to do it together? We can try and do it together. All right. So as we go forth and we get better at getting into our Chromebooks and our lessons, hopefully you guys will be able to do this on your own. But it says, press the show set 1 button, 2 new bars and expressions appear. Drag point X so that it does not equal 1. What do you notice about the length of these bars? Okay, so let's see what they're talking about. Show set 1. Okay, so if I drag this, what happens?
So big. Oh,
they multiply exponentially, right? What else do you notice they do?
Which one was part of it?
Oh, you think it's doubling? Yeah, it could be. Oh, pretty soon it becomes none. All right. So what do you notice about the lengths? Do the 2 new bars match any existing bars? Yeah, they don't really match, do they? Yeah, you can't tell from this. That's fair. All right, do you see how when I go this way, it goes back in that order? That's interesting. Yeah, you're right. Why won't? All right, now can you tell? If I leave this right here, what do these match? They x to the 5th. You notice this is x times x to the 4th, and this is x squared times x to the 3rd. So what's similar? How do you think they're related? How did they get 5 from x times x to the 4th? AJ?
It's basically x times 1 plus x to the 1 plus 4.
Good. So x is really x to the 1st power. Anytime we just have a base, it's to the 1st power. So they really added the exponents. So do you see how they added this 1 plus 4 to get 5? So they also added the 2 plus 3 to get 5. Do you see how this is going to work? Are we starting to get clued in here already, hopefully? All right. Point X can be dragged to the right and left. We got that. The numbers across the top of the sketch represent the value of X. We figured that out. The value of each expression is equal to the number with which its point is vertically aligned. Yep, we got that as well. If the bars and expressions go off the page, it means the value is greater than 15. To see the ends of all bars, move the orange point back to the left. All right, we figured that all out on our own. We didn't need the step by step. Cool. All right. So let's move on. Press show set 2. 3 new bars and expressions appear. Drag point X so that it does not equal 1. All right, so let's look at this next set. So now what do they equal? What do these 3 equal? X to the 6. So they're showing that this is X to the 1. So 1 plus 5 equals 6. 2 plus 4 equals 6. And 3 plus 3 equals 6. And that is happening when we are multiplying. They're multiplying those exponents, those powers, I guess we would call them, right? Okay, that's set 2. See if it's going to give us another one. Make a conjecture about how you can simplify a product of powers with like bases. So if the bases are the same and it's a product, we're going to do what with the exponents? Add the exponents if the bases are the same. Well done. All right, here's show set 3. Let's see this one. Okay. Is this one still true? 1 plus 6 is 7, 2 plus 5 is 7, and 3 plus 4 is 7. Does it work? Excellent. See, I don't even have to teach you. We're figuring it out for ourselves. So how can you simplify a product of powers with like bases? We keep the base the same and we add up what? The exponents. Yep, the little numbers, the little guys. We got to add them up. Okay. So that is our explore. How can you simplify a quotient of powers with like bases? That's what we're going to do. Isn't this the same? Oh, quotient of powers. I'm going to skip ahead a little bit. We're going to come back to quotient of powers. Because first I want you to use the product of powers. All right. So right in your packet on page, whoa, what did I just touch? What did I do? All right, in your packet, a monomial is a number. Do you see where it says this under learn? A variable or a product of a number and one or more variables. Oh my goodness. So a monomial is just like one term. For example, 6y squared is a monomial since it is a product of 6 and y squared. The expression x plus 3 is not a monomial since it is a sum of 2 monomials. So anything with a plus or minus between them, it separates the term, okay? So it's only one term. So when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. Sorry, a monomial only has one term. So mono must mean one. The expression x plus 3 is a sum of 2 monomials and therefore not a monomial itself because it has 2 terms. So we're going to drag each expression to the appropriate bin. An example of each type is given. Is x a monomial or not a monomial? It's one term, right? 80. Is this a monomial? Is it one term or more than one term? It's just one term, right? How about x plus 5? Not a monomial. How about 8x? Monomial. Remember, if they're being multiplied, it's still one term because it's that answer would be a product of those two numbers. How about x squared minus y squared? Not a monomial. Excellent. Okay, here we go. Page 14. We are going to learn product of powers. So we're going to watch this animation to see what happens when two powers with the same base. That part's important, right? They have to have the same base are multiplied. Product, multiplication, product. So we're gonna watch how we would simplify a product of powers.
You can simplify the product of powers with the same base. Write 4 squared as a product of factors. Write 4 cubed as a product of factors. There are 5 common factors altogether, so the product is 4 to the 5th power. Notice that the sum of the exponents of the original powers is the exponent in the final product. You can multiply powers with the same base by adding the exponents. The product is x to the 7th power.
Cool. So that's what it showed you there. In those notes on your packet too. So you can simplify a product of powers with like bases using the product of powers property. The group of integer exponent properties is called the laws of exponents. So we're going to be talking about these different properties. One of these laws of exponents is the product of powers property. So we're going to select each card to learn about the product of powers property. Words. So to multiply powers with the same base, we add their exponents. Do you see where it says that? On the bottom of page 14 under words. And then right to the right of that, it says algebra. So a to the m times a to the n is equal to that same base with the sum of those exponents added together. So numbers is still on page 14, right to the right, and I notice we do need something in that blank there. So let's flip this last one. So 2 to the 4th times 2 to the 3rd equals 2 to the 4 plus 3 power, or 2 to the what? 7th. So that's what you should be writing in that box on the bottom of page 14, 2 to the 7th power. Questions on that on page 14? We're on page 14. So when simplifying a product of powers using the product of powers property, why do the bases have to be the same? So why couldn't I use the product of powers property to simplify something with different bases? Why do the bases have to be the same? If I wrote this out and say x was 2 and y was 3, and I had 3 factors of 2 and 2 factors of 3, could I simplify it out to be 1 power? It wouldn't work, right? My factors are not the same in those power rules. All right, even. Example 1, we're multiplying numerical powers. So simplify 5 to the 4th times 5. So how can our powers property help us simplify this? What would it be? 5 to what power? We would say, what is our power of just this base of 5? What is it, Anna? 1. So we would say 5 to the 4 plus 1. That's what we think. So first we're going to write the expression. That's what they did. Next, we have to know that 5 is equal to 5 to the 1st power, right? They showed that as well. Then we can say 5 to the 4 plus 1. That's our product of powers property. These are all in your notes at the top of page 15. And then we have to add the exponents. So 4 plus 1 is 5. And then we can simplify. Now, we're going to be using our calculators a lot more because it's very easy to put in 5 to the 5th power. And we'll be talking a little bit more about that. We're going to use that little caret function quite a bit. So 5 to the 4th times 5 is equal to 5 to the 5th, you can write here, or 3,125. You see what you're writing there? All right, this check, they want you to check that you are understanding that. Oops, I didn't mean to check that one. I meant to do this. So another method you could use is to write it out, right? You can write out the products. What's up, Logan? You lost. Okay. All right, so we are going to check ourselves. Maybe here it is. All right. 4 to the 5th times 4 to the 3rd. So you can write it out, or you're going to write the two bases and do what? Add the exponents. Write down how you would simplify it. You don't have to multiply it out. Just write how you would simplify it and write it as a power. 4 to what power? Yes. Perfect. So this should be 4 to what power? 8. 4 to the 8th. Excellent. Now I want you to check this one. Remember, our extra examples are not in our packet, so you're just going to write it out next to it. I'd like you to write out the problem though, right? So right here you can write out 9 to the 3rd times 9 to the 2nd power is equal to 9 to what power? 3 plus 2 is 5. Can we do that? That's pretty simple, right? We can do these, I hope. You're right, this one is not on our paper. Is that what you're saying? This is an extra, but I want you to write it out. All right, example 2. After we do this example 2, I'm gonna have you do a couple of the practice problems. So if we're simplifying c to the 3rd times c to the 5th, this is the same thing, except we have letters in place of our numbers. Do we have the same base? Yes, because it's the same letter. We can assume that it's the same if they're using the same letter for it, right? So here we go. Right in your packet, you have this on the second half of page 15. So they wrote the expression c cubed times c to the 5th. Then using the product of powers property, we can say that that equals c to the 3 plus 5. And then that equals what? So you need to write that in, c to the 8th power. That's what we're writing in here on page 15. So c to the 3rd times c to the 5th equals c to the 8th. And they already put that on our packet. So now we just need to think it through. Explain why you were able to add the exponents, because c, they're both the same letter, so they're the same base, so we can add the exponents. All right, so this is your check on the bottom of page 15. It is x to the 4th times x to the 6th. So be sure this is equal to, all right, let me slide this over. This is equal to x to the 4 plus 6, which is x to what power? 10. All right, I think there may be one extra example. Yes. So it's good practice. Remember, this is not on your packet, so you can stay right on page 15. Simplifying this, so I'm going to write a to the 3rd times a to the fourth. The bases are the same, so I can simplify it by adding my exponents. I'm keeping my base the same. I'm saying 3 plus 4. So this equals a to what power? The 7th power. Now, I would like you to turn in your packet to page
21.
23. 23, and I'd like you to do numbers 1 and 2. Do numbers 1 and 2. So those are the ones you're going to do on your own, numbers 1 and 2. I think we'll try and do a little bit more back and forth than saving the entire practice for the end this time around and see if that helps. Does that sound fair?
Done.
Get out, guys.
There.
Anybody else need another second? All right. So the first one, what exponent is this base of 3 raised to the second one? I know. Sometimes it goes out on me. Which exponent is this 3 raised to? 1, right? So this is 3 to the 8 plus 1. What's 8 plus 1? 9. So that would be 3 to the 9th. If I gave you your calculator, you would be able to answer that like lickety split, right? What's my base here? M, right? This is m to the 5 plus 2, so you should have m to what power? The 7th. Excellent. Okay, well done. So we've already got a good start on our practice. Multiplying monomials. Now, when you multiply the two monomials, what will we do with these coefficients? Well, first of all, what are coefficients? The number in front of the letter. Those are our coefficients. So I have a coefficient of -3 and a coefficient of 4. So we got to think about what are we going to do with those? This is on page 16. It should be example 3 at the top. So move through the steps to simplify the expression. So first of all, we need to know the definition of a coefficient, right? Whatever we're multiplying this by, the coefficients are a number, okay? They kind of wrote it out for us then. Now, using the commutative property and the associative property, it doesn't matter what order we do them in, and it doesn't matter what we associate them with. We can combine them with parentheses either way. We are going to simplify it this way. We're going to multiply the coefficients. So they said -3 times 4, which is what? -12. And then they have to use our product of powers property to add our exponents. So do you see what you wrote in this first box here, where it says multiply the coefficients? They said -3 times 4 is -12. So you should have written -12 right here. Then the product of powers property, and then they simplified. So they just added them together. So this would be -12 x to the 7th power. That's how we would simplify. So -3x squared times 4x to the 5th power equals -12x to the 7th power. And that's what we're saying. All right. So when simplifying the expression, why were the coefficients multiplied but the exponents added? Yes. Yes, you got it. So we can multiply them because they're really just factors. So we just multiplied them together to simplify it. And our check. All right, So we're checking there. It is negative 2a times 3a to the fourth. Negative 2a times 3a to the fourth. So we're checking that. We'll start tomorrow with our extra example. So I want you to be sure you are answering this check before you start neatly putting your things away, because we only have about 2 minutes left. Be sure you're completing the general idea about page 16. So tomorrow we'll start with our extra example, do a few more practice, and then we'll move on to quotient of powers. Question, Logan? You need to get the actual chapter. All right. So that's all she wrote today.